You know how pi is like 3.14 and change? Well, along those same lines, e is a number, and it's like 2.71-ish. It's a number. E is a number which they'll introduce, like they'll tell you where it comes from, pre-calculus, calculus, one of those fancy classes. But they introduce it now, and we just accept what it is for now. E is a number. E is a number. It's not a variable. It's just a number. So recall the other day that log base A of B equaling C implies that A to the C is equal to B. We introduced that the other day. Now, instead of regular log, we have this thing called a natural log, a natural logarithm. And it goes like this. Natural log base E, A equaling B, that implies that E to the B is equal to A. So when do I use log? When do I use natural log? For our purposes, to make this simple, if you see the number E, be prepared to use natural logarithm. If you see the number E, be prepared for a natural log. If you don't see the number E, then you won't use natural log. You'll use log. For our purposes, just to be consistent here, that's how we'll run with natural logs. So some examples. Example here, so put this down. Let's say we want to solve these equations. So example A, let's say you have 5 to the power of x equals 100. So I don't see E, so solve this with log, a regular log. And based on your notes from last time, this would say log base 5, 100 equals x, and you're finished. Because the goal was to solve for x. And we want the exact answer, which is what this number is. That's the exact answer. A weird decimal? Nah. They want the exact answer. Boom, there it is. All right, what about example B? Let's say we have E to the power of x plus 1 equals 7. Well, now we do see E, so you're going to need a natural log. So look at your notes and look at the conversions. To convert this into natural log, this would say natural log base E 7 equals x plus 1. And then if you subtract the 1 to the other side, you'd get your final answer. Natural log base E 7 minus 1 equals x. Box that in. Done, done, done. That's the exact answer. Now, a quick FYI. Natural log always has a base of E 100% of the time. So for instance, you can just watch them copy this. Natural log E of, let's say, 5. In your textbooks, I don't think you'll ever see them write E for natural log because it's understood. It's the default setting. So you'll never see a little E there because it's always there if it's natural log. So on your exam, do you have to put an E down there if it's a natural log? You don't have to. You can, but you don't have to because it's understood to be there, period. All right, how about this example? This equation, equation C, natural log, let's say x minus 4 equals, let's say 5. Solve this equation for x. Okay, so I would begin by filling in the invisible base, which is what we just discussed. If it's natural log, it will always 100%, it'll 100% be a base of E. So go ahead and put an E right there. Now, convert this into exponential form. This would say E to the power 5 equals x minus 4. And then add 4 to the other side, and we are finished. E to the power of 5 plus 4 is equal to x. Done. What about this one here? What about example D? Let's say something that sort of mixes and blends both worlds. E to the power of 8x plus log base 4 16 equals natural log of e to the power of 5. Something that sort of combines everything. All right, so recall your fundamentals from the other day. Log base 4 of 16. Recall how this works. You want 4 to become 16. So what power do you have to raise 4 to become 16? Well, that's just 2. So we know that that's just 2. You can use calculator if you want. Heck, type that into a calculator and you'll see that it's just going to be 5. You can use your calculators on this. So let's see. So we have e to the power of 8x plus 2 equals 5. Go ahead and subtract the 2. So we have e to the 8x equals 3. And now turn this into natural logarithmic form. As a natural log, that equation would say natural log base e 3 equals 8x. And then to get x alone, just divide by 8 and we're done, right? Just divide by 8. So final answer, let me write this down. Let me write this down over here. So our final answer would be x equals natural log base e of 3 all above the number 8. All right, one more for today. Example E. Check out what this says. Example E, we have natural log of x in parentheses plus the natural log of 4 in parentheses equals the natural log of, let's say, 2x plus 7. So what about a situation where we have logs everywhere, like all over the place? Well, I would ask myself, can I just type this into a calculator? Well, here, no, because there's a variable. Here, no, because there's a variable. And here you could, but that'd be a weird decimal. So here it's like, how do I, there's logs all over the place. I know how to solve an equation if I see one, but I have 3. I have 3 logs here. So in order to solve this, what we need is this, look. We need log properties. Log properties are needed for you to solve this equation. And guess what our next meeting is about? Log properties.